Hey everybody, I'm back. So I'm sure everything is broken, so let me know if you can actually hear me. I need some kind of confirmation that everything is back. Let me know. There we go. I'm seeing some comments from people that are live. Um, I apologize. My voice is going to sound a little froggy today. The smoke from western United States is lingering in the air across a big chunk of British Columbia, and I didn't think it was going to be a problem, but it's actually kind of in there. I'm definitely feeling a little mucky in my sinuses and throat. I've been a little hehemy, so I apologize in advance if I do this. So welcome back to an all new season of all of the stuff that we do. Say hi in Chinese, sure, ni hao. Um, Welcome back to an all new season of everything that we do here on my YouTube channel. For those of you who don't know, of course, I take a hiatus over the course of the summer. We turn off all of our live streams over July and August, dial back a lot of the other projects, and really just focus on resting, recovering, thinking about other projects, developing new stuff for our website. Remember that what I do here on YouTube is just like one small piece of my actual career, which is that I'm the publisher of Universe Today. Had a great summer. Apart from not being able to go places and see people, that sucked. But yeah, it was good. It was restful, relaxing, and now we've got lots of stuff coming back at you. So we just released a new QA today. We've got new open space. We've already done the new astronomy cast. We were going to do a new episode of the virtual star party, but then again, because of the fires, because of the smoke, most of our telescopes were taken offline. Just like smoky skies. I don't think anybody, I know some observatories were destroyed, but our astronomers were fine. And now we were able to reschedule for this Saturday. But if the weather's still, like if it's still really bad, we may have to push back another week. So hopefully we'll be back. The other big change that I'm making is, there's some people that really like these live QAs with me, other people that really like the guests. Why choose? Let's just go with both. So my plan is to invite a guest on every week at a separate time than when we do this open QA. I'll probably keep the open QAs on Mondays at 5 o'clock, and then I'm gonna try to do the guest shows at random times, really any time that works for them, and partly that'll help with the people who are like, some people in Australia never get a chance to see any of our live stuff, or other people in Europe never get a chance to see our live stuff. So for some guests, I'll interview them in the morning. Other guests I'll interview in the afternoon. It'll be different days depending on what's best for them. And that will allow me to get the best possible guests here on the channel so that I can get some of the coolest interviews, because I will make it appropriate to their time, whatever that is. So I hope that works for all of you. Big day, of course. Huge discovery announced that one of the key byproducts, a very rare byproduct of life, phosphine, was discovered in the cloud tops of Venus. And the researchers spent 3 years checking, double checking, trying to think of any possible reason why it could be anything other than life. And they weren't able to disprove themselves, find any error in what they did. And so they went and announced it today. And now, of course, the rest of the scientific community is going to do the same. I actually just finished writing up the episode for this. So Chad is editing it madly right now. And hopefully we will be able to release the episode. I'm not sure, maybe tomorrow, maybe the day after that. Depends on how quickly Chad gets cracking on this. All right. So let's go into the show. And if anybody has some questions they want to talk about, or if you want to actually talk about this Venus discovery, I definitely can do that as well. I've had a chance to, like I said, I just wrote my script, just did my whole episode on it. I think my version of this is going to diverge from a lot of other people's work on this, because there's a really interesting paper that came out about a month ago by Sarah Seeger and a bunch of other researchers. And Sarah's one of the actual people who worked on this discovery of phosphine as well. And so I think she was telegraphing that they knew that they were going to find phosphine. She's been talking quite a bit about this idea as phosphine as a biosignature, as a chance for evidence of life on Venus. And so she did this paper, and her team did this paper, and now here we are suddenly, and what do you know, there's the discovery of this really key biosignature. So anyway, so I talk quite a bit about that and talk about sort of the mechanism for how life could survive on Venus. What could it be doing to be able to remain in an environment that's so hostile? If you fall too far down, you bake in an oven. So all right. So Arjun is asking, could life on Venus have come from Earth or even Mars? Yeah. So if we get to the point where life is absolutely confirmed on Venus, then the question is, did it come from Earth? Are we related? And this, of course, leads back to this idea of panspermia, that life on Earth is related to other life in the solar system. And the way this would work, theoretically, it hasn't been proven, but every piece of this seems to be possible, is that you've got some mechanism for kicking life off of planet Earth. And that can be like giant asteroid impacts. That could be just the solar wind interacting with the Earth's atmosphere and blowing material out from the top of the atmosphere. And then that material would move around in the solar system. And so we know that if you have like an asteroid impact, material can be thrown up into the atmosphere and up into space and survive. And in fact, some Japanese researchers were able to recover life from the seafloor that was 100 million years old, and they gave it the chemicals that it liked, and it popped back to life, ready to go. So we can definitely see that life can survive really extreme conditions. Then life would have to transport somehow across through space, just drifting for millions of years. And again, if it's just completely exposed to the sun, to the radiation of the sun, then it wouldn't last. But if it can get inside, under the crust of the rock, a few centimeters even, then it can survive and be protected, and then it can desiccate, it can dry out, and just wait for a chance to reach an environment that's more hospitable to life. And then the last piece of the puzzle is for life to actually re-enter the Earth's atmosphere, re-enter the atmosphere of another planet. And once again, we know that asteroids can do this, that they can enter the atmosphere of some other planet and not burn up and actually protect the life that's inside, so it just lands hard on the ground. Or in this case with Venus, maybe is able to make it into the atmosphere, but not actually make it down to the surface. And so you've got this mechanism. This is, of course, the term is panspermia. You've got this mechanism for being able to go from the surface of Earth out into space and then back through the atmosphere. And so if life is found on Venus or found on Mars, one of the first things that people are going to want to do is figure out if it's DNA based. Does it have the same kind of mechanism that life on Earth does? And if it is DNA, RNA based, are we related? You can trace back the tree of life all the way back to the point where we and Venusian life has a common ancestor. And that's kind of neat. So we're still a long way. And sort of the crazy part is it sort of feeds into this idea of the Fermi Paradox, is that if we do find life on Venus, we do find life on Mars, possibility one is that we're related. And so it doesn't answer the Fermi Paradox, because now suddenly it still feels like we're all related on, all life on Earth and all life in the solar system is all related to each other. And doesn't tell us if life formed independently of Earth. But if it is independent, if it's a completely different life form, then suddenly you've got this possibility that life has formed 1, 2, 3, 4 times independently here in our solar system. And that just means that life has got to be everywhere. And then, of course, if life has got to be everywhere, then where is it? So it's a pretty fascinating time. All right. Let's see. So T260 asks, do you have any chance of any updates on the Arecibo radio telescope and perhaps funding to get it fixed? Yeah, so we covered this on Universe Today just on Friday, Saturday. So they are now working on Arecibo. As for those of you who don't know, the Arecibo radio telescope, you know, the big dish that was seen in like the movie Contact, or if you've played like Battlefield 3, I think you get a chance to destroy the Arecibo Radio Observatory, and a guy line broke on that supports the sort of the big instrument panel that hangs above the dish, broke and smashed down and crunched a good chunk of the observatory, or of the dish. Didn't do any damage to the electronics, any of the other instruments, but it definitely struck the dish. And so it's going to be down for a couple of months, but they are in the process of repairing the telescope now. So it'll probably be back as good as new. The problem is that Arecibo was already pretty starved for funds. You know, for a few years there, it was kind of touch and go whether or not it would even continue. And so at this point, to have to spend millions of dollars to repair a telescope that was already sort of at the extreme end of its budget is kind of a scary situation. So hopefully we'll get back to a point where it gets back operational. I mean, it's such a key instrument, especially when you think about, you know, its ability to, say, scan near-Earth asteroids, fairly dangerous objects that are passing by the Earth. It's a very useful instrument, and it would suck that if it got totally taken offline. All right, so James Hapgood asks, do we have any missions to Venus coming up that expand on this paper? So I actually did 2 videos about 6 months ago, maybe it's a year ago, I'm not sure how long ago. One to missions that would go to the surface of Venus, and one about missions that will go to the atmosphere of Venus. And the good news is there's 14 missions that are either in the works, in development, or even just in the conceptual stage that could go to Venus. Some combinations of orbiters, balloon missions, and landers. The sort of most reasonable one, there's one called Da Vinci Plus. But like bad news, we talked about a potential mission to Neptune and Triton. And so one of the missions that could go to Venus. There's 2 missions that could go to Venus, a mission that could go to Io, or a mission that could go to Triton. Pick 2. And maybe a month ago, people would have said, you know, Triton, Io. But now, suddenly, with the discovery of phosphine, now all eyes are going to be on Venus. So I think it's going to be a tough time for people to pick which of these missions is going to go. And that's the Da Vinci mission. But there's another even cooler mission that would actually be dropped like a balloon that would float in the cloud tops of Venus and just travel around and around and around the atmosphere. It's called VICE, the Venus In Situ Composition Explorer. And then actually the Indian Space Agency is working on a balloon-based mission for Venus as well. So, and you can imagine timelines being pushed up, that budget will start to flow for all of these missions now that a very key ingredient. I mean, when we think about what's off to Mars right now, we've got the Perseverance rover, we've got the United Arab Emirates mission, and we've got the Chinese Tianwen mission all off to Mars, plus Curiosity on the surface, plus InSight, plus Reconnaissance Orbiter, plus Polar Orbiter, plus there's so many missions at Mars right now. And suddenly Venus gives off a more compelling key biosignature for life than anything that Mars has done to date. So that's interesting. It's sort of like you can imagine suddenly the space agency screeching the brakes on Mars missions and starting to look seriously at Venus missions, which is pretty cool. So Bobby Reynolds asks, we all know that a giant planet would disrupt the solar system if it intrudes. Could a small planet like the size of Mars do the same? So I actually covered a fairly similar question to what you asked in the question show like today. So if you haven't had a chance to watch that, then definitely do that. And you know, it all depends on speed and size and how close it gets to various objects. So, you know, if Mars hits Earth, then you get the complete destruction of the surface of the Earth. It gets inverted. It gets turned into molten magma again, blobs out the moon, and the Earth is pretty much destroyed or unlivable for hundreds of millions of years until it cools down to the point that its surface can form again. So a direct hit of a Mars-sized world would cause extinction level events. If it got close but didn't actually hit, then it could do things like disrupt asteroids as it's coming through the solar system, which would then go on to interception paths with various objects in the solar system. It could also interact with gravitationally with worlds like Earth and Venus and Mars and Mercury, just depending on how close it gets. The larger planets like Jupiter and Saturn would just tear it apart. If it got close enough, their tidal forces would just rip it into pieces, and then the pieces would just form this stream of material that would eventually smash back into the world, like what happened with comet Shoemaker-Levy 9. If it got farther away, then it wouldn't cause too much of a gravitational interaction, make the planet wobble a little bit on its orbit, but not much. Jeff Horn asks, how much credence do you put into the Venus news? I suspect we're going to talk about Venus quite a bit today. Let's see. So the discovery of phosphine, this chemical, there aren't a lot of processes that can produce it naturally in a rocky environment like Earth or like Venus. You can get it in a place like Jupiter or Saturn where the planet is largely made of hydrogen. But to get it in a place like Earth where the atmosphere is largely made of oxygen, it's mostly nitrogen, but large amounts of oxygen. Same thing with Venus, large amounts of oxygen mixed in with the carbon dioxide. So you would have a really hard time. It's very reactive. It's one phosphorus atom and 3 hydrogen atoms. And those hydrogen atoms really want to be with oxygen, and they want to jump away from the phosphorus as soon as they can. And so you don't have any real way for it to be sustained for long periods of time. So there's got to be some process on Venus that is actually producing this material. And the process that is, some of the possibilities are things like volcanoes. But you would need like 200 times the volcanic activity that Earth has to produce and sustain that kind of phosphine. You could have like constant lightning strikes, but again, you need just lightning at a level we don't see. Meteorite impacts happening on Venus, which we just don't see. So there just aren't any natural processes that should be able to produce it, and yet there it is in the atmosphere. It's only like 20 atoms per billion atoms of the atmosphere, but it's still enough. And so we'll sort of look at the chain. So the first thing is this phosphine there? And the astronomers did very rigorous science to prove that it is there. They used the James Maxwell telescope first, the James Clerk Maxwell telescope first, and then they used the Atacama Large Millimeter Array, which is one of the most powerful telescopes. It's a radio telescope on Earth to be able to study it, and they found a very clear signal that this phosphine is present in the atmosphere. So I think anyone who looks at the evidence is going to have a really hard time disputing the discovery, the observation of phosphine in the atmosphere. So then the question is the phosphine created by life? And there's no evidence that it is, but there are very few things that can create it naturally, as I mentioned, in an oxygen-rich environment like the atmosphere of Venus. So where we're at right now is it's not like bacterial life has been directly discovered, but there is a clear biosignature. And this is the whole the whole thing that's going to be behind the future exploration of biosignatures of exoplanets, right? That we're going to be able to observe these exoplanets and sense these biosignatures like phosphine, like methane, like ozone, large amounts of oxygen, water, things like that in the atmosphere, and then try to build up a puzzle about whether or not there's actually life there. And so this is just like the perfect place to do it, because you can gather all this data, and then you can send a spacecraft to double check and say, was there life? Was everything that we thought that was happening, the mechanisms that we were seeing, did that match to life? And Venus, it's way easier to check Venus than it is to check Gliese 582 or something, some planet that's 1,000 light years away, and we will never know for sure. We'll go, we think there's life there, but we can't know for sure. Well, if we get to a point where this phosphine really does hold out, and they do send probe, and they do find microbes, they figure out what's going on, then you have a lot more certainty that there's life on these exoplanets as we discover them. And phosphine has been proposed as like the perfect biosignature, because it is only produced, like, if you see it on a gas giant, who cares? Gas giants aren't going to have life anyway. But if you find it on a rocky world, it's very unusual, and it's a really good indication. So I think so it looks like the phosphine is certain. What's causing it is unknown. And there could very well be a mechanism for creating phosphine that nobody ever knew, nobody ever thought of, and will just immediately prove that it's not true. All right. Let's see. So Ron McCoy is asking, most biomarkers should exist with other biosignatures. Any evidence for this? So I guess you're asking, phosphine is just one example of a biosignature, but there should be potentially other biosignatures. And so far, this is a brand new field of study to try and figure out biosignatures. For the longest time, astronomers, astrobiologists were very, not flippant exactly, but they were very, they felt like a lot of chemicals that would be seen, say large amounts of oxygen in the atmosphere of a planet, or ozone, or things like that, would be clear evidence that there's life on that world. And now we know that there are natural processes that can produce almost every kind of chemical that we can imagine. I mean, methane is produced here on Earth by burping cows and bacteria, but there are natural processes that can produce methane on other worlds. And the problem is that when you do chemical analysis of the atmosphere of another world, you don't get to know how much of the atmosphere is made of that chemical, only the presence of the chemical at all. So it's not as comprehensive. And so if we see, say, methane, if we saw oxygen at 20, I forget what it is, 21% or something in the atmosphere of another world, then that would mean that there was life. But you would just know that there is some oxygen, not exactly how much there is. And so it's each one of these biosignatures that astronomers are going to try to find, each one is going to be hard won, that they are going to try to, I'm sure many of you before today had never heard of the chemical phosphine, and yet it is perfect, that it is rare on planets in high oxygen environments, so the rocky planets that you want. It is produced through life and very little else, and that's what you want. It is very reactive with the atmosphere of an oxygen-rich, a very Earth-like atmosphere. Therefore, it should be disappearing very quickly. And so if you see it, then it means that something is sustaining it for long periods of time. It's the perfect biosignature. And so the hope is that they will find others, that they will find a collection. Eventually, they will have a whole toolkit, and they'll say, okay, let's scan the atmosphere and let's see, do we see phosphine? Yes. Do we see biosignature number 2? Yes. Do we see biosignature number 3? Yes. And so by finding all of those, but each one, I know that phosphine has taken a long time for people to come and be quite comfortable with that as a very recognizable biosignature. So this is the first one. This is the first time. And so very exciting to see this discovery made on Venus because it's so close. And so now you can just go and find out whether or not it's real or not. Arjun asks, how flexible is Starship and where it can go? Well, right now, Starship is a flying grain silo. We've seen Starship. I mean, over the summer, big news happens over the course of the summer while I take the hiatus. It happens every summer. And so we saw the Starship launch twice. 2 separate prototypes of Starship made to flight. 150 meters, so just a hop and then landing. But apparently now the next version that's going to fly, I think it's going to be SN8, is going to be the full hop to go to an altitude of 60,000 feet, about 20 kilometers. And it's going to be equipped with the wing flaps, and it's going to try to do this hammerhead belly flop maneuver. So it's going to fly up, and then it's going to fall back down, tummy first, with its flaps, and then it's going to try to kick out that bottom and land propulsively. And that's a serious upgrade over the current one. It's going to have these flaps. It's going to have 3 Raptor engines. It's going to have a full tank of fuel. And we should see this flight later on this year, maybe early into 2021. But more likely, we'll see a bunch of prototypes explode. And then it'll be maybe SN10, SN12 that actually is able to make the flight. So, it's a bit of a preamble just to sort of catch everybody up on what's happening with Starship. It's very exciting, and yet it's obviously feels like it's going agonizingly slow, and yet it's going incredibly fast, especially compared to the other giant rocket systems that are out there. Not going to name any names. So what can it do? I mean, I've mentioned this sort of time and time again, is that our imaginations are not prepared for what the Starship can do. There are no rocket systems on Earth that can launch the kinds of payloads that Starship can do. And when you think about how it can do it in a reusable capacity, it's just orders of magnitude. It's 10, 100, right, times more capable. And so what I think we're going to start out seeing is we're going to see these Starships just everything that's going to be put in a Starship. Like even it's like a CubeSat. It's cheaper to launch a CubeSat out of Starship and a full Super Heavy, although it's ridiculous, than to launch it on a Rocket Lab or something smaller, just because the thing is fully reusable. And then we're going to see much sort of missions that are designed with Starship in mind. We're going to see super heavy versions of spacecraft. Like what if you could send 10 tons to Saturn as opposed to 1 ton or 2 tons? What if you could send that to Pluto? You could send a rover and a lander and an orbiter and a ton of fuel to both slow down and speed up to be able to get there and make the mission happen in a very short period of time. And then when you adapt this whole idea of orbital refueling, then there's literally nothing that we can't do, because you could launch a Starship, refill it with fuel, and then away you go, wherever you want to go in the solar system. So the promise of Starship is to usher in an age of solar system exploration, the likes of which we've never seen before. And literally, our imaginations are not able to grasp the outcome. In the same way that if I said, what could you do with a computer? Like if we're back in 1980 and we're playing on a PC and I say, or 82, I go, wow, now can you imagine if this thing was 1 trillion times faster? And you'd be like, I don't even know what we could do with that. Well, it turns out video games and internet and cameras and all kinds of stuff, right? We just don't know. And so it's pretty exciting to see what's going to happen. I think we're still going to see, we're not going to see the Mars, the people set foot on the surface of Mars by 2024 as originally planned. I mean, the timeline of Mars by 2020 is still the official, like the first cargo mission is going to be sent to Mars by 2022, and then the first humans to Mars by 2024. But like maybe it takes 2026 or 2028. That's fine. It's like we've been waiting 50 years since Apollo. So if we need to wait an extra couple of years for them to get the engineering right, I'm perfectly fine with it. Hearthstone, we could play Super Pong. Can you imagine Pong, but a trillion times more Pongy? All right. Let's see. So MC Creations is saying, Fraser, now imagine we send a probe there, find life forms, and they also have some kind of DNA. It would confirm so much about abiogenesis. So back to this idea of sending a mission to Venus, right? Like if we could send a mission to Venus and we could detect, we sample these tiny little droplets of sulfuric acid mixed with water dissolved in, and inside the water, there's life forms that are surviving, and you take those life forms and you bring samples back to Earth and you examine them and you find out they have DNA, but the DNA is not related to us, then suddenly you've got this mechanism for life. We should see DNA everywhere. That this is clearly the way that life forms. Just fascinating ideas. So no matter how this plays out, every possible way that this plays out, it is exciting. If we do find life on Venus and we do find that it is related to Earth, that's exciting because it means that life has gotten around, and there's probably life everywhere across the solar system, evolving into all kinds of strange forms that adapt to their environment. It means that Earth life can probably survive wherever it needs to go. But if it is completely unrelated to us, then it means that life forms all the time, everywhere. So yeah, I'm pretty excited about it. Pacer, this is hype to drum up extra funding. Extra funding for what? Extra hype for what? There is a set amount of funding that goes into space exploration missions, and you just decide where you're going to send the target. And so you either send the mission to Venus, or you send the mission to Mars. And we saw what happened back with the announcement of life on Mars back in 1998. I remember that. Scientists announced they found life on Mars. Did that lead to a rise in funding? Did funding get drummed up? No. Funding just kept on declining, just like it does. Just every year, little less money gets spent on space, little more money gets spent on the military. So I think even if they find life and it's waving to us in their little cameras, it'll still mean a slow and steady decrease in funding for space exploration. So yeah, good luck with that. There's literally nothing that could be discovered in the universe that would increase funding for space exploration. Nothing, except for maybe oil on Mars. That might do the trick. All right, so apologies. T260 asks, Fraser, do you think the first Artemis mission to land on the moon will have 2 astronauts or 4? I know it's set up for 4 astronauts. Curious if it will be 2 astronauts on the first mission for safety. So what's going to happen with Artemis is still kind of shifting, and where we are right now today is that they're scaling back how the Artemis missions will begin to focus on the landing date and less on the changing the mission, the sustainability of the exploration. It's moving towards a recreation of the first Apollo landings and less as an entirely new way of exploring the moon. So originally the plan was that you would build the Deep Space Gateway. And the Deep Space Gateway would be this it'd be the space station that would orbit in an orbit that took it very close to the moon. And you would use all of the skills that were learned with the International Space Station, but you would build a very, very mission-specific space station that would be close to the moon. And then astronauts would fly to the Deep Space Gateway. They would get into their lunar landing system. They would fly down to the moon, ideally reusing as much of the system as possible. And then they would get in there, do whatever exploration needed to be done, and then they would fly back up to the moon, and then maybe they would just stay there and then do another mission down to the moon, or maybe they would come back to Earth. And so you would have a way that was very different from the way the Apollo missions worked. It was very long-term sustainable, where you're just constantly flying to and from the moon. Eventually getting to this point, you've got this permanently habitable, inhabited base on the moon, in the same way that we've got a permanently inhabited base in space right now. There are astronauts that have been continuously in space for over 20 years, which is pretty exciting to think about. And so you'd have something similar, but on the moon, and eventually on Mars. But to meet the timeline of 2024, the scale of the mission is getting decreased. And so now, instead of it being like going to the Deep Space Gateway, the first mission to the moon will probably be 2 to 4 astronauts who will be on the Space Launch System. They'll fly to the moon. They'll land in a, say, Blue Origin, Blue Moon lander, and then come back to Earth. So it'll essentially be exactly the same mission as the original Apollo missions, and definitely not set up for any kind of long-term sustainable return to the moon. So, maybe it's a political move. We'll see. Or just everyone's just like just whatever it takes. Let's just go to the moon, meet the date, and then figure out the most we can do. And now the latest thing that we're seeing is that the actual use of the Space Launch System as the necessary rocket is starting to be scaled back. And so it's entirely likely that big chunks of this mission will be done on a Falcon Heavy. So instead, and we're even seeing the possibility that a Crew Dragon could be adapted to be a moonlander. And so you might have a Falcon Heavy launching, meeting another Falcon Heavy, passing over a stack that includes a Crew Dragon and a Blue Origin Blue Moon lander, and then that's what flies to the moon, lands, and then the astronauts come home. And that could be done for a fraction of the price of the full Space Launch System SLS. It could be done within the time frame as well. So though everything is up in the air right now, I would not be surprised if we saw the SLS get scrapped or put on the back burner and use more off-the-shelf stuff like from SpaceX using Falcon Heavy. Then, of course, again, back to Starship. If Starship flies, then everything changes, and we're just using Starship. So, Event Horizon. That's John Michael Gaudier's channel. How long would a Crew Dragon last on the surface of Venus? Anything that goes to the surface of Venus lasts for about an hour, and then they die, robotically screaming. And that's spacecraft that are designed to really handle that kind of environment. A Crew Dragon, I can't even imagine. I mean, remember that going to the surface of Venus is like being under 1 kilometer of water. So imagine you took Crew Dragon, put some weights on it, and just dropped it into the ocean and waited till it made it all the way down 1 kilometer under the ocean. It would get, I believe, smirched is the technical term for that. So that plus the heat, we have no kind of spacecraft that can handle it. And yeah, sending astronauts down to the surface of Venus, that would be murder. Hemtech. So in order to go to Mars, should we have a Mars space station too? You don't need a Mars space station to go to Mars. And I know if you ask, say, someone like Robert Zubrin, he will deeply disagree with any more infrastructure at all. Just start throwing rockets at Mars, have them land. And there's something to be said for that. That's the plan for SpaceX. They're just going to launch from Earth. They're going to refuel in space, and they're going to go to, they're going to land on directly on Mars. They're going to pass through the atmosphere and land on the surface of Mars. The idea that I do like, there's two ideas that I like as well in addition to that. One is that you do leave from, say, the cislunar orbit. So you need less change in velocity to launch from the orbit around the moon than you need to go from Earth. But people call that a toll booth to go to Mars. The other idea that I really like, and we did a whole video on this, is that you build a base on Phobos. Because Phobos is almost Mars, but it's a lot safer and easier to get to Phobos than it is to get all the way down to the surface of Mars. And so you take a spacecraft, go to Phobos, arrive at Phobos, you got a base on Phobos, hopefully not a portal to hell on Phobos, and then you refuel your spacecraft, resupply, hang out with the astronauts, and then descend through the Martian atmosphere and land in whatever is the minimum spacecraft required to get you down to the surface of Phobos safely. Surface of Mars safely. The problem is that that the Martian atmosphere is too thick and too thin, and so it's a very dangerous atmosphere to try to get into. It's one of the most dangerous places to try to land on in the entire solar system, except for maybe, the sun. And so that's why, as I've said, Mars eats spacecraft for breakfast. We are going to see deaths as people attempt to land on the surface of Mars because it is so dangerous. And so any way that we can decrease the risks being able to land will be great. Larry Beckham asks, what is the crush depth of a Crew Dragon? I don't know. Peaks and Pokes asks, how long can balloons survive in the Venusian atmosphere? So we did a whole episode on balloon missions to Venus, but the atmosphere of Venus rotates around the whole planet in about 3 days. So if you can stay at the right altitude, you can go all the way around Venus really fast. And so get a ton of data. It's the perfect place to go. Plus, you're in the middle of that atmosphere. And then if you build your balloon, it can sink down. If you sort of change the buoyancy of your balloon, then it can sink down into the atmosphere, collect some material, and then float back up and sort of get another trip on those really fast winds and then sink back down. So as I mentioned earlier in this video, there are a couple of missions that are thinking of going to, sending balloon missions to Venus. And so I'm sure now with this discovery, we should see these balloon missions get fast-tracked. I wouldn't be surprised if we see them by the end of the decade. There you go. Jason Geddes, I just answered your question. Arjun asks, were there any parts of the Venusian surface that were untouched by the resurfacing event? Is there life in the atmosphere? There must have been something down there. No, it looks like the entire surface of Venus completely resurfaced. It just turned itself inside out. But one of the things that I've been trying to look into, and I couldn't find anyone mentioning this, but there are, it's thought that there's more life inside the interior of the Earth, like below the surface, inside in the rocks. There's as much biomass in the interior of the Earth as there is on the surface of the Earth. And couldn't that also be the case on Venus, that there could be just enormous amounts of material that is under the surface, as deep as it needs to go to get away from the heat of the surface, but also not be in the heat of the interior of the planet? And maybe there's still water trapped in the rock. So I couldn't find anyone who had put any numbers or any proposals on that. I'm going to keep looking, but it feels like that's another way that life could survive. And so, but to transport life from the surface of Venus up into the high atmosphere would be tough. It's just so awful. So you need to have a way that life is remaining in the high atmosphere. And like I said, our video coming out tomorrow, I think, we're going to talk about the mechanism that could do that. The short version is that you've got droplets that essentially, like when you get droplets in the Earth's atmosphere, it builds up more and more liquid over time, and it gets heavier and heavier and heavier, and then it falls as rain. But on Mars, on Venus, what you could have is you could have these bacterial creatures living inside these droplets as they're forming, and they're getting bigger and bigger and bigger, and then they are spraying out spores that rain down towards the surface of Venus. And then they get down to about 30 kilometers or so, 35 kilometers, and the atmosphere thickens up, and you get this haze, this hydrocarbon, or this haze in the atmosphere of Venus. And in that layer, then it becomes very dry. And so these particles could survive a long time desiccated, these spores. And then droplets could pick them up and carry them back up into the higher atmosphere, and they could spring to life, quickly hurry through photosynthesis and produce more of these spores, and then throw them out into the atmosphere, and then they sink back down to this haze level, and then wait for another trip up. And so that's how the life might be continued. And one of the things that's interesting is that, like the kind of life that we have on Earth, it doesn't need to be that efficient to be able to produce that much phosphine. It just needs about like 10% of its current capability to be able to produce that. So, what are my thoughts on which, Jameson? We're talking about the life on Venus. What's Scott Manley's runway project? I got to check that out. Has something to do with runways and Scott Manley. That sounds fun. Kyle Hunt asks, what's more likely, that we spread life to Venus or they spread it to us? I would say at this point that it's more likely that we would spread life to Venus than vice versa. It's like on Venus, there's just like one way that life can just barely survive in the atmosphere of Venus, and it's clinging on. While on Earth, there's lots and lots of places for life to try all kinds of different ideas. So I think that's the assumption. But again, more evidence is necessary. Hal McKinley, what would it take for a self-sustaining human-made space city? How huge would it have to be? So self-sustaining, I think, is the question, which is how you need power, you need to be pulling in resources from the asteroid belt or from asteroids, and you need to be generating its own artificial gravity to support life on the space station. I don't know how big it would be. There's a pretty interesting paper that we found. We're working on a story on Universe Today about it, but it's this idea of growing a space settlement in layers. So think about, say, the shell of a snail, where it's a spiral and it has like more and more chambers as it gets bigger and bigger and bigger. And so you could grow a space station, a rotating space station, just getting more and more chambers, getting bigger and bigger and bigger as your space station gets bigger, and still keep it roughly able to rotate and self-sustaining. So we're looking at this paper, and I may do a video on it as well if it works very well. Visto 2D asks, did the Russians spread life to Venus? So, wherever life goes, wherever our missions go, we send our filthy Earth life. So you could imagine that the life survived the trip to Venus and then made it through the atmosphere, and then I guess was kicked off as it was falling down and then made it into the atmosphere. But it wouldn't. So maybe, but it wouldn't explain the amount of life that we're seeing, right? Like you would need to have, like, maybe a couple of microbes could have survived, but it would be hard to explain it getting around to the entire planet, producing phosphine at these kinds of levels. That's the kind of thing that had to have been there for hundreds of millions or billions of years. T260. I know the hype is around Venus, but I'm curious about the return Pluto mission, if it will be another fly-through orbiter or lander, and hasn't been approved yet. So I think we talked about this like a year ago, but Alan Stern, who is the program manager for New Horizons, is of course he's Pluto. He's a big Pluto fan, and he has proposed a Pluto orbiter slash lander mission rover, and it's in the proposal works right now. There's no official news on whether or not it's going to be accepted, but like, be patient. An orbiter to Pluto, like, unless you can get your hands on a nuclear rocket, you're looking at a very long flight time, because you have to take a very long trajectory to be able to get into an orbit around Pluto. So that would be amazing, but we're looking at, 20 years to get there. So, Horizon Brave, Fraser, what would you have to see to happen to start investing money into the stock of space mining companies, for example, moon mining, asteroid mining? Nothing. There is no thing that would happen that would make me be willing to invest money into an asteroid mining company ever. There's just no financial reason to mine asteroids and bring the resources back to Earth. There's like, even if you make rockets free, it still doesn't make sense to mine asteroids, because there's just so much material here on Earth. Better to mine the oceans for gold. If you're so low on gold that gold has got expensive, you just pull it out of the seawater. What asteroid mining is going to be really good for is in situ resource acquisition. So if you're on the moon and you need building material, or if you're on the moon and you need metal or water or volatile gases, then the best thing to do is to pull that material from the moon. If you're on Mars, the best thing to do is to pull that material from Mars, where you are. And if you're living on an asteroid, then the best thing to do is to pull it off of an asteroid. But it will never make financial sense to bring that stuff back to Earth. And we see asteroid mining companies go out of business all the time. It's like it's one of the easiest way to lose money and go bankrupt, is to try an asteroid mining company. Same thing with space power. Like, it'll never make financial sense to harvest your power from space. It will always make more sense to harvest your power just down here on Earth. Solar panels are incredibly inexpensive and getting cheaper every day. So it's that when you go out into space, when you've got that city that we were talking about, now suddenly it makes a ton of sense to do asteroid mining, because you don't need to pull all of that material out of a gigantic gravity well. You just slowly move it over from the asteroid's orbit to your space station's orbit. And so all of this technology is very important. In situ resourcing, I mean, I talk about this all the time. Space-based manufacturing and resource acquisition are critical technologies that we're going to need, but we will never see the benefits down here on Earth. The benefit we will see is when we see that space station flying overhead, and we know that humanity now is living on multiple places in the solar system, and they are gathering their resources from the asteroid belt. That's when we know it's going to work. Let's see. Robot Guardian, do you think the creation of Martian colonies will be live streamed? Well, no, because the time delay from Mars is about 2 minutes at the closest point and about 20 minutes at the longest point. So it'll always be ping times of, somewhere between 2 and 20 minutes, average 12 and a half minute ping times to go to Mars. It won't be live streamed. But will there be live video coming from Mars? Eventually, yes, but in the short term, Mars will, it's just so difficult to communicate large amounts of data from Mars. And so even as they set up huge radio antennae on Mars to be able to communicate data back and forth to Earth, being able to actually send data to Mars is going to be a very precious resource. And so I can't imagine that just some live stream camera going all the time, gobbling up gigabits of internet is going to be the most efficient use. I mean, you can imagine there's going to be like a nightly synchronization of Wikipedia so that people can engineer new things on Mars, or there's going to be 3D printed new devices for the robot factories, things like that. It'll be a long time before like high quality video is the thing that makes a ton of sense to send. Arbola 29 says the University of Arizona is getting a grant to work on quantum entanglement communication. That's awesome. The Chinese actually already have a pretty cool quantum entanglement communication system. So it's used for encryption. You can tell if somebody is eavesdropping on your communication if you're sending it using quantum entanglement, but that doesn't allow you to go faster than the speed of light. Pacer says the ISS has 24-hour streaming. It does, but the International Space Station is only 400 nautical miles above the Earth. And so it's, what is it, 400 kilometers? Anyway, a lot closer to be able to communicate with. And NASA has a network of giant dishes that it uses to communicate with the International Space Station. To go all the way to Mars is, is a much slower bandwidth to be able to send. All right. Well, we've got 3 minutes left to the end of the show. So I just want to remind everybody that all of our various live streams are now all happening. We put in the newsletter, we've added a gadget that shows you every upcoming live stream across all of our channels. So when the next open space is going to be, when the next guests are going to be, when the next astronomy cast, etc., weekly space hangout. And so you can sort of set notifications, reminders. Everything is available by podcast. So if you can't join me live and you don't want to sit in front of YouTube, you want to listen to this conversation while you're on the bike, everything's on a podcast. And I link to everything that we've done in my weekly email newsletter. So just go to universetoday.com/newsletter and you can sign up for the newsletter. Thank you, everybody, for joining me today. It was a lot of fun. I'm so glad to be back and talking, and we've got tons of stuff. Like I said, new QA dropped, this episode on the Venus discovery. We've got we're talking about a Titan submarine mission, this expandable habitat, and a one-person spaceship, which will essentially allow you to do very rapid spacewalks that you just hop in your little spaceship and fly around. So as opposed to getting out in a spacesuit and trying to do a walk around. So we've got lots of cool ideas. But thank you to the moderators. Thank you to everyone who watched me today. I really appreciate that. And thanks to the people who donated. That was wonderful. Thank you so much. And I will see all of you at some random time, probably later this week, with a special guest randomly to be determined. So stay tuned for that randomness. All right. Thank you, everybody, and we'll see you all later on.